Graphing exponential functions with transformations. I have 5 examples, and the first 4 are single transformations, and the last one will have it all. As you could see on the right side, we have f of x equals b to the x. That's my exponential function. And with the transformation, I called it g of x equals a times b to the x minus h plus k, just like the vertex form. The first example, we need to graph g of x equals 3 times 2 to the x. Knowing 2 to the x, which is called the parent function, with the key points 0, 1 and 1, 2, as you could see right here, 0, 1 and 1, 2, because anything raised to the power 0 is 1. We have 2 to the power 0 gives me 1. So 0 gives me 1. If we plug in 1 for x, we have 2 to the power 1, and that's its 2. So we need to keep this in mind as we go. Now, g of x equals 3 times 2 to the x is one type of transformation, which is the following. A equals 3, that's my a, that's my 3 right here. A equals 3, which is gonna give me a stretch vertically by a factor of 3. So what happens when you stretch vertically? When you go vertically, y gets affected, not x, and 1 becomes, those are the key points, by the way, the ones that are mentioned right here. 1 will get affected by 3 times, and it will be 0, 3 instead of 0, 1. 2 will be affected vertically by a factor of 3, so times 3, 2 times 3 will be 6, and that is the new 2 points or key points. So the graph will look like this. 0, 6 instead of 0, 1, and 1, 6 instead of 1, 2. That should do it for number 1. Number 2. The transformation that is happening right here is the negative sign up front, which means a is negative 1. If a is equal to negative 1, we have to reflect the graph in the x-axis, because if this is called y, if this is y, what we have here is minus y. So the new function is minus the original y. So the y values will be, instead of being positive, will be negative, reflected in the x-axis. So this one right here, when you reflect in the x-axis, instead of being 1, will be negative 1, and instead of 2, will be negative 2. The graph will look like this. 0, negative 1 right here, and 1, negative 2 is down right here. That's a reflection in the x-axis. That should do it for number 2. Number 3, we have this type of transformation, and that is taking place right here. As we know from the vertex form, this transformation will translate 2 units to the right. So this will affect the graph to go to the right 2 units. When you go to the right 2 units, it's not y that's going to get affected like example number 1 and 2, it's x. This x will be moving to the right 2 units. It's not going to be at 0 anymore, and x equals 1 is not going to be at 1 anymore. So when you move to the right 2 units, this point will move 2 units to the right, will be right here, and this point will move to the right 2 units, will be right here. And 0 will be 2, adding 2 to x, adding 2 to 1 will be 3, and that's the graph. So as you could see, we're moving 2 units to the right, and we're moving 2 units to the right. And that should do it for number 3. Number 4. The transformation that is taking place here is k equals 3. Just like the vertex form, when k equals 3, the graph is going to go up 3 units. So this point will go up 3 units, and this point will go up 3 units, which means the y value will increase 3 units. 1 becomes, that's 3 units up, 1 becomes 4, and 2 add 3 units will become 5. Here's the graph with the original one. So the points are moving up 3 units, the key points, and that's how we get the graph. Number 5. Number 5 has everything in it: graphing exponential functions with transformations. We have the -3, so a is -3. We have x minus 2 on top, that is x minus h, which means h is 2, and plus 4 outside, that's k. K is 4. So, what type of transformations do we have here? For the function given, compared to f of x equals 2 to the x, first, a equals -3 has 2 effects: reflect in the x-axis because of the negative sign, and stretch vertically by a factor of 3. So what happens to 0, 1? 1 gets multiplied by -3, so it's going to be -3. Let's move on with the transformations, and we'll apply to the points. Second part is, we said h equals 2 right here. That's a translate 2 units to the right, which means the x value will move to the right 2 units. We'll be adding 2 units to x. And finally, adding 4 outside, that's k equals 4, will translate 4 units up. So, one by one, let's apply the 3 transformations, a and h and k, to this point. So we have 1, 2, 3 transformations. Applying -3, multiplying by -3, 1 becomes -3. Translating 2 units right, x gets moved to the right, x values moved to the right 2 units, so 0 becomes 2. Of course, y, we keep it -3. Adding 4 to the y value, because we're moving up, we add to the y value, add 4 to -3, or move this point to -3 up 4 units. 4 plus -3 will be 1, and that is 1. So the final point is 2, 1. Let's apply the 3 transformations again to this point. For the first one, multiply by -3. That's multiplying the y values by -3. We have 2 times -3 will give me -6, as you could see right here. Now, moving 2 units right, x gets affected by 2 units being added. 1 becomes 3 by adding 2 units. So it's 3 -6. And moving up 4 units, the y value, we add 4 to it, it becomes -2. So that's my final point, taking it from this point, and this is my final point, taking it from this point. Now keep in mind that it's reflected into the x-axis, so it's not going to look like going up it's gonna look like going down. So here's both graphs. This point is 2, 1. That's this point right here. And 3, -2 is this right here. You connect them and we're done. Thank you.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.